Good morning, everyone, or good afternoon, or good evening. It's really good for you to join us and to be here. My name is Tim Curris, and I'm the moderator or chair for Conference Room 2 for today's proceedings. In my day job, I'm the Programme Director at the Society of Maritime Industries, and we're the trade association for the UK's maritime engineering and marine science and technology sector. And one of the interest groups which I run in that job is the Digital Technology Group, which looks at the impact of digital technologies right across the maritime sector. So we're really pleased to be able to sort of support this conference, which specifically looks at the impact of digital technologies in maritime, and indeed this session today, which is focused around smart shipyards. So we've got a packed agenda themed on smart solutions for the shipyard, but also exploring smart vessel design and how both can be used to drive improved vessel lifecycle management. There's some really great looking, interesting presentations, which I'm really looking forward to hearing. In this morning's session, we have speakers from Naval Architect, International Marine Industries, ProStep, and Delta Marin. Each session will last around 25 minutes, which includes 5 minutes for questions at the end, and of course 20 minutes for the presentation itself. Please do use the Q&A section on the right-hand side of the screen for questions for the speaker. There's also a chat function which you can use to leave more informal comments or communicate with each other. But if we can put the questions for the speaker in the Q&A section, that would be greatly helpful. And in between speakers, we'll be going off screen to backstage to just to make sure we're all ready, and then come back on, so there'll be a short dwell between speakers. But I'm pretty sure that will run pretty smoothly, and we're aiming to run through to lunch at around 12:50. Okay, well, that's enough from me. I'd now like to introduce our first speaker. It gives me great pleasure to introduce Sebastian Greshake, who is the Managing Director and founder of Naval Architect. And he's got a PhD in naval architecture. Sebastian's going to talk to us about process automation for maximum efficiency and reliability in shipbuilding. Over to you, Sebastian.
Okay, thank you. Thank you for the introduction, Tim. So we had a short chat before the meeting, because my name, as you might see, is horribly difficult to pronounce correctly. So my name is Sebastian Greshake. I'm really glad to be here on the Shipbuilding and Lifecycle Technology 4.0 conference this year. And yeah, as Tim already said, I'm representing Naval Architect. Actually, I'm not talking too much about this product today in this presentation. But as we are fairly new to the market, I would just mention that we have also a virtual booth here on the conference. So if you're interested, please have a look, and let's try to get in touch if that is something for you. So what I want to talk about is basically how we could automate processes in shipbuilding in order to improve the efficiency and reliability of that thing. And yeah, in order to understand that, the first thing we need to look at is how today's enterprise IT infrastructure looks like. So I say enterprise IT infrastructure because I know this is not fairly the case for each and every shipyard, especially the smaller ones might look a bit different. But my first career was at Siemens, and this was more or less, let's say, enterprise grade as it could be. And this is more or less how it looked like at this company as well. So what we see, and what the point of this slide here is, we have two large bubbles of different IT systems, which are more popular in all enterprise corporations nowadays. This is on the right side here. On the right side, it's the CAD plus PDM space. So something like Siemens NX plus Teamcenter. And we have, of course, the ERP section, which is typically something like SAP or maybe Oracle. They have both a certain overlap, which is typically the bill of materials. But what we want to see here, and what I want to stress, is that not all departments are equally well connected via these systems to each other. So, of course, if you have a look to the engineering department, this is perfectly supported by CAD and PDM, and this works as it should. I mean, we can always argue about user interfaces in certain places, but after all, I think that problem is well solved. It's not completely true from my experience in shipbuilding. It's not completely true for the design department, because most of the time, if you're in early design stages, that full CAD and PDM flow is maybe a bit over the top. And on the left side, it's maybe the interesting thing. There's many satellite departments which are somehow connected to the ERP world, but maybe not so much to the CAD world. And my career, as I told you before, started at Siemens. So I was at production planning at this time. And although I'm an engineer, I not even had access to a CAD system, because we were mainly working with the ERP system. But it took, let's say, one hour a day or something. You just check out certain things, you do your job, and if you finish that task, you will be publish back your results. In shipbuilding, from my observations, this has really a large impact on how we organize ourselves. Because if you take the example of how we communicate which kind of paint should be applied to which tanks on a ship, you see what happens. So the design department may specify, okay, ballast tanks should have a special anti-fouling coating. So that's a requirement essentially. And then already the question is, how do we communicate that to the engineering department? And what happens if engineering then decides, okay, this needs to be translated in a specification of 3 layers of Tank Guardian 2000 coating? And I mean, we all know these typical questions. Project management asks, okay, what is the status of paintworks? It needs to know, of course, what kind of paintwork is expected here. Procurement might want to know how much paint I need to order. Logistics wants to know who needs how much paint at which place. Production, what should I paint in which way? Commissioning, is everything painted as expected or specified before that thing is handed over to the customer? And when I've prepared these slides, I've asked a colleague of mine who has 10+ years experience in the industry, hands-on, and he told me each of these bubbles you're showing here is 10 stupid emails, 10 times wasting time. So what we can conclude here is, although we have the 2 massive systems, it's not really solving all problems that we face nowadays. And that comes at a price. So you need to pay for that. And we all know, I believe, the famous study of McKinsey stating that 1 hours a day on each employee is spent on searching information. This is what we have seen on the last slide, in essence. And there's numerous other studies confirming this finding. So about 20% of your time is wasted searching for information. In other words, if you have 5 people, one of them is not adding any value because this person is just searching for information. And what I personally believe is much more important in shipbuilding is this does not only account for extra costs in various places, but this also accounts for error costs. Because if you have trouble to locate information, you might run into the risk to make design errors or production errors. And this is in the end the more costly aspect of that thing here, and might even get your entire company into troubles. And if we take those 2 figures here, multiply that basically with a typical project structure in shipbuilding, we say that 5 to 10% of the overall costs is addressed by this issue, by this challenge here. And this might not sound too much on the first place, but actually a well-running shipyard has a profit margin of about 5%. So we are really talking here about the huge thing you can get out of it. You could get out of it, let's say it this way. So what we really need to do, and from our point of view, in order to improve on that situation, we need to shift from the process on the left side. So this is like an abstract illustration of the same problem, where everybody is somehow speaking to each and everybody, and different kind of communication channel, different kind of data sets sent back and forth, to a streamlined process as illustrated on the right side, where those stakeholders are collaborating on a central model. And we call that thing ship information modeling. It's very much the same from building, like building information modeling, as we know from the construction industry. And the important thing I want to emphasize here is the ENG. So it's a process, you're doing something, namely to manage project data based on a central digital model. And I believe that idea is not so mega new, even in the shipbuilding industry. But so far, we haven't really got to that point here. And this is because we need to talk about how that model should be structured. So, but before we do that, just missed that slide here, to be honest. Before we do that, we may reconsider the example from before. So exactly the same problem. What happens if you would just have that model? So let's have a look to the design department. They do the requirement. So they input something into your model that is somehow made available on that model side. The engineering takes a look into the model, can immediately identify what the requirement is, and will then add further information, namely what kind of tank coating needs to be applied in which way. And for all the other stakeholders discussed so far, it's just looking into the database. It's just asking the user interface to bring up the data they really need to know. Something like for the procurement, let's take this example. Just ask the model, okay, how much paint of TG2000 type I need to order in total, and then you know what you need to do on that side precisely. So as I said before, I think the issue to make that, to get this thing to life is that we need to talk about how that model should look like in order to support that process effectively. And I think the great mistake which is always made in our industry is that we believe a CAD model is the model that we need as the central source of information in our process. This is here the dimensions 2 and 3. So 2D space is the drawing space, of course. So you have basically flat documents describing your ship. And we have the 3D geometry space, which is essentially the space covered by modern CAD systems. So you have a 3D geometry representation of your hull systems, components, and so on. But I think that is not enough if you really want to change the process as shown below. What you additionally need is the fourth dimension, the specification dimension. So a structured representation of all relevant functional and physical characteristics and relations. And this is what typically lives in Excel sheets, in Word documents, or just in the people's heads. Of course, if you try to collaborate in larger teams, the fifth dimension would be handy. So now who has changed what at which place? We call that the history dimension. And if you would just have that model, you could also think about what else I could integrate. And this is, for instance, the sixth dimension, the simulation dimension. So you could try to simulate your model to make to decide on the behavior. And the thing which is now the hype thing, I would say, in our industry, the digital twin. You could also try to get that into a feedback loop with the reality. So basically bringing back sensor data and similar things into the model to further improve it. In order to make ship information modeling happening, I believe at least maybe the fifth dimension is needed, but for sure CAD is not sufficient. Why not just 3D CAD? I really need to stress that point because it's so often done false from my point of view, because it's neither a digital model nor a digital twin. So a CAD model in essence is a sophisticated form of a drawing to represent geometry more precisely. And that makes absolutely sense because when we moved decades ago from paper-based drawings to AutoCAD, let's say, of course, people raise the question, if we are now using the computer to model things, why don't we increase the dimension to the third dimension? Because what we actually want to describe is a three-dimensional thing. Makes absolutely sense. And this is what CAD systems were built for, and this is what they do really, really well from my point of view. But they lack some information, and this is namely the physical and functional characteristics and the relations. And this is required to speak of a digital model. And if that digital model then in a next step would live in a feedback loop with reality, we would talk about the digital twin. And I really need to stress that point because I think in our industry, there's a tendency that those buzzwords are used to a certain extent in the wrong way. So even I myself, I'm now, let's say, like 10 years plus in the industry. I had already the moment on my side where I thought these buzzword things are bullshit. But I think this is not true in the meanwhile, because if you're able to describe a complex concept in a single word, this is really an art. And yeah, we really should appreciate if people do that well. But I think in our industry, there's a tendency that we pick up these words from other industries and just start using them without really understanding what they are all about. And this is basically in the moment happening in the digital twin area, because many people who have just still a 3D CAD model now claim it's a digital twin. And I'm pretty sure if you try to implement those kind of processes, which are expected from that, based on that model, you will fail and nothing will change anyways. So I know, of course, these kind of arguments are a bit difficult. You might believe me, maybe not. You might believe in my arguments here, maybe not. But I think here in this case, it's pretty easy, because if you recall the picture which we have discussed in the beginning, the enterprise grade state-of-the-art process, IT enterprise landscape that you would face in large-scale corporations, you see that we already apply CAD and PDM for decades. I think CAD is now 30 years plus, PDM maybe 2 decades approximately, I would say. But you use that on a large scale in your everyday business, and nothing has changed in the way we have discussed before. So if you don't listen to me, listen to your experience, because you know already that this won't work out. Yeah, that is what I wanted to highlight here. Of course, as introduced here in the beginning, I represent Naval Architect. That thing is, of course, as you might all know, fairly new to the market. So the interesting question is probably on your side, what is the difference that we make? And I won't go into details right now, but I think the main difference we offer is that we implement the industry's first 5D digital ship model. So it covers all 5 dimensions stated earlier. It's not just a 3D CAD model. It also has the 4th dimension, the technical specification. It also has the 5th dimension, the project history. That all is running in a cloud so that all people can access that thing easily. And it's made specifically for shipbuilding. So that entire model was crafted with shipbuilding requirements in mind. But if you're really interested in that, I think it doesn't make sense now to turn that presentation here into a sales pitch. I mean, we are here on a conference, we have a virtual booth, and we also have, of course, a website and many other channels you can reach us out. If you think what I've told you guys today, there is some truth in it, I would warmly invite you to ping us, to align on a 30-minute session where we talk about your challenges in order to figure out which processes we can make more efficient and reliable based on our technology and which not. And the thing I can promise to you here is if we do that, you get an honest answer from our side, what we are capable to do and not to help you. Yeah, that's my presentation up to this point here. If you don't visit our booth and don't visit our website, of course, you can always reach me as well here. I'm online. I'm a normal attendee on that conference. So just reach out to me and get in touch with me.
Fantastic. Thank you very much indeed, Sebastian, for that expose of ship information modeling and how Naval Architect goes about it. Please do stick any questions you have in the Q&A section. There's none there at the moment, but I'm going to lead off, if I may, with a couple of questions for you, Sebastian. I think you really sort of summarise well the process of ship information modelling, and clearly it seems like a pretty comprehensive framework. Can you just give us a bit more sort of richness in how you think it's going to help to transform, digitally drive that digital transformation in shipbuilding?
Yeah, I think if you ask it this way, it's a good question. I think in essence, if we talk about digital transformation in shipbuilding, this is, if not the component, the main component of digital transformation, because I would compare that with our daily life. So if we just recall how our daily life has changed, how we communicate with other people, how it is now possible to book flights or trains in minutes, this is where we see basically what kind of effects such kind of central models with easy access to information and easy updates do have. And I think this is what would happen in the shipbuilding industry as well. And that's why I would claim that the general idea of ship information modeling is basically a synonym, so to say, for digital transformation in our domain.
Yeah, got it. I think it certainly looks that way. So Charles has got a couple of questions actually. He's asking what is the back-end CAD and PLM software you're using? And his second question, if he's using another CAD right now, like NX or Ship Constructor, how easy is it to switch?
Mm-hmm. Yeah, so our backend, geometric modeling backend is Parasolid. So essentially like Siemens NX. We do not say that you would need to switch from Ship Constructor, whatever you're using, to our system, but we would essentially talk about how to integrate both worlds with each other. And this would probably go using, for instance, something like Teamcenter. And that's really something I want to emphasize. So it's not that we're going to replace a normal CAD system, because you still need to have the detailed 3D modeling. I think that's very clear to everybody, and we don't do that. But we try to get out of your 3D models the data subsequent stakeholders are really interested in. And therefore, we would integrate both solutions. And then our solution is like the general purpose perspective on that 3D CAD modeling details.
Great. Thank you, Sebastian. Christopher Lou's got a question. Thanks for the inspiring presentation. How is data security ensured, especially for the military applications?
Yeah, military applications, of course, in most part of the world don't work out in our cloud application, of course. But what we offer for these kind of customers is that you roll out that internally. So basically, you run that system on your intranet. So it's as secure as your intranet is. For the, let's say, civil application, I would say, or non-Navy applications, I will always say, like, I don't believe, I always ask the question, okay, what is the main source where you lose data? And I believe this is when people switch companies. And they usually have the tendency to copy a few documents and take it over to the next company. And this is, I think, the greatest data leak, not only in shipbuilding, everywhere is faced. And this is not possible with our platform, because if an employee leaves the company, you just disable that person, and he or she can't access the model anymore. I think that's the great difference we make here. But of course, we know that many people are now interested in bringing up the Navy vessel production. And we are happy to support that, because this kind of complexity is what we are looking for. And in this case, we have the option to roll that thing out on your own servers. Yeah,
it's the beauty of this system. It wraps everything up. Adele's got a question. How can we relate the digital twin to finite element analysis and real-time analysis? And how would that be a benefit to the industry?
Yeah, so I would say, maybe I try to switch back here on that thing here.
Yeah.
Okay, it was, I think, skipped over. I think if you talk about finite element analysis, we are still in the 6th dimension. And this is what I mean by integrating physical models. So that's basically, you have your ship specified as it should be built. And now you would integrate, let's say, physical behavior to simulate certain things. And one option, a complex option, to be honest, is to integrate finite element models. And I think that would be a great plus. It's not directly supported on our side yet, but it would be a great plus, because you get more insights on your design early in the process, of course, and more easily. For the digital twin, I'm not so familiar with that thing. I really think that is, I'm most concerned about design, engineering, production processes. But once we reach the operating stage, so you want to operate your vessel and you might want to know certain things, this is, I think, really handy then to back couple basically your model with the reality.
Great. Thanks, Sebastian. Ozan's got an extension to Charles's question, and how data exchange downstream of ship design is envisaged. How much of the model can be used for the detailed production design?
Yeah, so we are currently in a discussion with a third-party company we want to cooperate with. But we think that you will, if you use a system, let's say like Siemens NX or Teamcenter, then we are able to fully integrate both worlds. So if you make a change on our side, you see that on the Siemens side and vice versa. So I'm pretty confident that our prototype will work here, and that should be well possible. Of course, it depends a bit on the system you're using, because a few of the shipbuilding systems are not so open as expected. And I think that's also something which was not mentioned here in my presentation today. But to rely on open APIs to communicate between systems is a core asset if you really want to drive digital transformation. And I myself, of course, face competitors which are not so open from mindset, of course. And I don't know what will happen over there, but I think there's a large risk on their side that they will lose track on that movement.
Okay. Yeah.
Maybe
Great.
not directly from other side at the moment, of course, as you all know, but if industry starts more and more moving into the digital transformation direction, then this will become an issue for them, with us or without us.
Yeah. Great. Right, we've got time for just one more, Sebastian, and that's Miguel's asked a great question. What do you think is the biggest challenge for shipyards to move from CAD and PDM to a digital twin currently?
Yeah, what is the biggest challenge? Yeah. I think shipyards are trying to minimize risk after all, and that's fairly makes sense, of course. And changing processes is always a bit of a risk. And I think the main challenge currently is that we need to convince shipyards and people, of course, to take this risk, because we strongly believe that this will pay off later on.
Yeah, indeed. Okay, Sebastian, thank you very much indeed for that great presentation, and indeed thank you to the attendees for your really stream of questions. There is one more left from Kim. I'm afraid we don't have time for that right now, Kim, but I'm sure Sebastian will be pleased to take that one offline.
Yeah, I will take up this one.
And please do use the system to hook up with Sebastian if you have any further questions. Great. Okay, well, with we're going to leave now and go back and get the next speaker, and Hatem El Gamiel, and we'll see you again soon. Thanks.